Okay, type 2 hypersensitivity. So this is cytotoxic hypersensitivity. Okay, so this is where an antibody binds to healthy cells and targets them for destruction. Okay. All right, so basically you've got some kind of body cell and the body cell sort of creates this antigen antibody sort of complex. And then what the antibody does is link it to some kind of like phagocytic cell or some kind of cell that will target that body cell. So there's a couple ways that it will do that, and it usually is mediated by IgG. IgG antibodies, but it could start the complement cascade. Against that body cell. So these are just the mechanisms, right? It could help a natural killer cell. Because basically, natural killer cells are lymphocytes, but they are they're kind of phagocytic. I mean, they aren't phagocytes, but they're kind of that way. So antibodies can act as opsonins to help natural killer cells target those body cells, because again, this is not something that's good. This is a healthy cell, and so the antibody is itself targeting the body cell and then telling the natural killer cell to go in there and target that cell. It will also do that with macrophages. So these are basically the mechanisms. So the antigen attaches to, or is attached to that host, and the antibody attaches to that on the body cell, and then it targets that body cell. So a couple diseases act by this type of little antibody antigen sort of complex thing. Goodpasture syndrome. And that is a kidney issue, a kidney disease, and it targets the glomerular basement membrane. So it basically targets the kidney. Graves' disease. And myasthenia gravis. are two diseases that this causes a problem. So in Graves' disease, it activates receptors for thyroid hormone. It activates them so it makes too much. And then in myasthenia gravis, it blocks the receptor for acetylcholine. Blocks acetylcholine receptors. All right, so that's type 2 hypersensitivity. And next we'll talk about type 3.